NeoTech Process, where next-gen factories, robotics, and sci-fi engineering come to life. In an orbital megafactory, we forge machines meant to cling to cliffs on distant moons.
At its core is the HaloDrive Explorer rover, a vehicle designed to quietly rewrite gravity.
On an airless moon, it hangs sideways on sheer ice, halo wheels shimmering against darkness. No tracks, no ropes, only invisible force lines from orbiting generators guiding it steadily upward. This rover ignores roads and friction, choosing instead to follow force lines written overhead. Halo magnetic wheels grip sculpted magnetic pathways, generated by a constellation of orbital field generators. Imagine invisible rails painted in magnetism through vacuum and rock. Its wheels swim along these gradients, clinging to cliffs, drifting over dust, gliding across impossible terrain.
To build it, we begin not with an engine, but with fields and elemental dust.
Asteroid dust floods vacuum conduits, rich with nickel iron, rare earths, and superconductor-forming elements. In gravity-neutral plasma furnaces, this dust reorganizes into ultralight alloys, foam metal frames, and superconducting threads. Conventional wheels are forged circles. HaloDrive wheels begin as levitating tori of pure potential. Inside growth chambers, seed rings spin in magnetic bottles, while supercooled ions weave perfect quantum flux lattices. Graphene ceramic shells grow around each core, impossibly strong yet flexing microscopically, packed with sensor neurons. Millions of embedded sensors feel stress, temperature, field strength, turning each halo wheel into an organ of perception.
Completed wheels drift into the alignment vault, a spherical chamber recreating the complex magnetism of orbit.
Concentric electromagnets line the walls as ultra-cold gas floods in, suspending glowing halos weightless at center.
Fields twist and sweep through the vault. Halo rings flare alive, responding, adjusting, and beginning to learn.
Machine learning cores inside each wheel optimize flux channels through thousands of patterns, crafting unique magnetic signatures.
Only after alignment with synthetic skies do the tuned halos join the waiting HaloDrive chassis.
Segmented limbs form a skeletal frame around a compact fusion core, its heat harvested by nested exchangers.
Along its spine, field-sensing masts rise like a dorsal fin, triangulating orbital fields for the halos.
Robotic arms choreograph assembly, mounting halo wheels, sealing joints with nano-welders, threading fiber-optic nervous systems. Inside bays, smaller field beacon drones assemble, then dock along the rover's flanks like symbiotic organs. Now complete, the HaloDrive glides into a colossal test hall, where activation and trial by terrain await.
Artificial cliffs, ice, and dust fill the chamber. Beneath an overhead array of full adjustable gravity falls to low moon levels as projectors hum, field maps bloom, and the halos ignite.
The machine flows instead of lurching, wheels pivoting within halos to ride invisible gradients up vertical walls. Physical contact stays minimal. The true effort happens in the thin boundary where orbit-sculpted fields handshake.
Dust storms, field breaks, power cuts strike. Drones extend local fields while wheels lock onto residual magnetism.
When the tests end, projectors fade and halos dim, leaving a silent silhouette of concentrated potential.
Deployed across the solar system, HaloDrive explorers redraw exploration maps, treating sheer cliffs and chasms as pathways.
On Mars, Europa, Enceladus, even comet spires.
Low gravity becomes ally, not hazard, as orbital generators sketch magnetic roadways no wheel has ever needed.
Colonies rise on and shaft of as halo doors spread.
Someday, beneath a dim, distant star, a HaloDrive will pause at the edge of an unspanned abyss.
There will be no road, only lines of force drawn across the void by distant orbiting machines.
As it steps into nothingness, it proves our future paths are carved into space itself, not ground.
If you enjoy the video, please like, comment, and subscribe for more.